We will now find the product and quotient of these given two complex numbers, that is z1 and z2. And so for this, we'll be utilizing this definition of the product and the quotient of the complex numbers. So suppose if z1 equals r1 times of cos theta 1 plus I sin theta 1, and z2 is r2 times of cos theta 2 plus I sin theta 2, then the product is given by this equation, that is z1 z2 equals r1 r2 times of cos of theta 1 plus theta 2 plus I sin theta 1 plus theta 2. And similarly, the quotient is given by z1 over z2 is r1 by r2 times of cos of theta 1 minus theta 2 plus I sin theta 1 minus theta 2. So we'll be utilizing this definition of the product and the quotient of the complex numbers to determine the product and the quotient of these two complex numbers. So first, let's determine the r1 and theta 1 of the complex numbers. So if you look at z1, this is r1 equals the modulus of the complex number, that is 6, and theta 1 is the angle, which is 100 degree. So I write down this as 100 degree. And similarly, when you look at z2, we see that r2 equals basically the modulus of the complex number, which is 2, and theta 2 is the angle of the complex number, which is 10 degree. So we can substitute into these two formulas. So first, let's find the product, that is z1 z2. So z1 z2 equals, we have to multiply the r1 r2, which means r1 is 6, r2 is 2. So 6 times of 2, and then we write down this in the form of cos of theta 1 plus theta 2. So I write down theta 1 is 100 plus theta 2 is 10. So this becomes cos of 100 plus 10. And then I sin theta 1 plus theta 2, which is 100 plus 10 again. Let's simplify this. So therefore z1 z2 equals 6 times of 2 is 12, and this becomes 100 plus 10 is 110. So it's basically cos of 110 plus I sin 110. So this is the value of z1 z2. Let's now find the quotient of the complex numbers, that is z1 over z2. And this is given by the second formula, that is we will utilize this formula r1 over r2. So we know that r1 is 6 and r2 is 2, so this becomes 6 over 2 times of cos of theta 1 minus theta 2. So it is 100 minus of 10 degree plus I sin 100 minus 10 degree. So when we simplify this, we get z1 over z2 equals 6 by 2 is 3, and this becomes cos of 100 minus 10 is 90 degree plus I sin 100 minus 10 is 90 degree. So this is the quotient of the complex numbers z1 and z2. Let's now find the product and quotient of these two given complex numbers z1 and z2. So here we observe that r1 equals the modulus of the first two complex numbers, which is 3, and theta 1 is the angle of the first two complex numbers, which is 150 degrees. And r2 is the modulus of the second complex number, which is 25, and theta 2 is the angle of the second complex number, which is 100 degree. So first let's find z1 z2, which is the product of the complex number. So we will utilize this formula, that is r1 r2. So I can directly substitute this over here. R1 is 3 and R2 is 25. So 3 times of 25 is 75, and then we have cos of theta 1 plus theta 2. So we have to add these two complex numbers. I'm sorry, these two angles, that is theta 1 plus theta 2, which is 150 plus 100 degree is 250 degree plus I sin 250 degree, because it is also theta 1 plus theta 2. So this is the product of the complex numbers in complex polar form. Now we'll find the quotient of the two complex numbers. So we write z1 over z2 equals r1 over r2, which is 3 over 25 times of cos of theta 1 minus theta 2. So it is 150 degree minus 100 degree, which is 50 degree plus I sine. Once again, it is 50 degree. So we have z1 over z2 equals 3 over 25 cos 50 plus I sine 50 degree. In fact, we can simplify this modulus, that is 3 over 25. When we write down this in terms of decimal, it is equivalent to 0.12. So we can write down this like this also, that is a cos of 50 degree plus I sine 50 degree. This is z1 over z2. So either we consider this or this form as the quotient of the two complex numbers.